Now on Mars itself, you've heard of these things called Gullies. Now these are not to be confused with the recurring Slope Lineae, that fun term, which are the little dark, well, I don't know, they almost look like little flows of water on Mars. So don't confuse these, I'll talk about those later. These are actually gullies. They look like water has carved out a path. However, we see material being left behind at the bottom of them. Up here is a gully, and down below material's being left behind. So something's cascading down. Well, we thought, could water be flowing? We don't see enough water to be moving this much material, and yet these things are clearly happening now. Between 1999 and 2006, this event happened, and there was no liquid water flowing in great amounts on Mars between then and 2005. So what could be happening? We thought maybe CO2 could be moving it. Frozen carbon dioxide, as it sublimes off the surface, could be creating these flows. That's the best example we have. Well, finally they used one of the orbiting cameras that can measure chemical compositions, and they looked for hydrated minerals, minerals that were changed by the presence of water, things like clays. They did not see them. In these gullies, they don't see evidence for hydrated minerals. The little bit they see is actually in some of the tailings and was probably made 3-4 billion years ago when Mars was wet. So no evidence in these gullies for liquid water. So the carbon dioxide mechanism for forming these is still the best and probably what is making them on Mars. So these are those recurring slope lineae that I mentioned before, the dark streaks that maybe these are water on Mars, liquid water, because that sure looks like water flowing down a crater wall. And maybe there's a big frozen layer that's warming up and a little bit of seepage is happening and it's seeping down the sides of the crater. A lot of people thought that. A lot of people were making models of being able to have this water coming out and, okay, maybe not tapping it and drinking it because it's going to be really briny and salty. But still, interesting. You think place of liquid water. Well, studies come out, and let's take a look at some more. I think we've got another one here. And you can see the time going by. The date is in the upper corner. So these appear generally in the spring and summertime, especially on walls that are facing the sun. So facing the side the sun's coming from. They were seen in a lot of craters, which again was making people think maybe there's a layer of ice that could be feeding these. Others, however, were saying, well, let's map these out and think about their locations. And they're seen all across Mars, but a lot of them are in Valles Marineris, which is the biggest canyon system in the solar system. It's a huge canyon. It's the size of essentially the United States. If you go from the left side of it to the right side, it would stretch all the way across North America.
So you think Grand Canyon is super. Imagine US-wide length of a canyon.
Yeah, and this is the canyon here, Valles Marineris, and it's very, very low there. So the atmosphere is a little thicker. Sometimes there's fogs that we can see and cloud layers down in there. So maybe something else is happening. If we step forward, this is a study, just a recent study they've done. They've studied something like 36, 37 of these sites. Some of them have thousands of recurring slope lineae. So this is not a small study. They went in with a high-rise camera up on the Mars Reconnaissance Orbiter and took high-resolution photos of these to see their locations. Now, some of these are located in areas like here. This is a little ridge in the middle of the valley, like a mountain peeking up. Some of these are located not along the walls, but along sort of freestanding peaks and ridges. If we step forward one here in the slide, you can see a high-res image with a lot of recurring slope lineae. But this ridge here, there's no layer of ice that can be feeding these. It just can't happen, not for the amount of time that these have been going on. The ice would have been frozen out 3 billion years ago, so there's not 3 billion years worth of ice along that ridge. So at least some of these cannot be formed by an underground reservoir of ice to feed them that's melting. Instead, we think that it's salt that was left behind on the surface, maybe by an original seepage, maybe by a seepage that happened billions of years ago, and then these salts are pulling the moisture from the atmosphere. It's something that's called deliquescence, and that the salt can actually pull the moisture right out of the air. It can form droplets, it can form little streaks along the sides, so there is liquid water there. It's just not seeping from underneath. It's probably coming directly from the atmosphere. Valles Marineris does have, I forget how many Olympic swimming pools worth of water down in it, but it's a large number. But to get that much of it onto the sides of the walls and in these recurring slope lineae is a little difficult. So they still have a problem to figure out, well, how exactly is this happening? Maybe not all of them are formed this way. Maybe some of them are still ice seepage, the ones along the crater or along the walls that have crater walls rather than these. But The mystery's unraveling. We're getting more information, more data, and it's interesting. I have a little demo of deliquescence for you to see here. This is a cucumber slice with a piece of salt up above it. And over the course of a few hours, you can see this droplet appear above the cucumber slice right on the salt crystal. So this is deliquescence in action. And then it'll touch the cucumber and be sucked into it. So that's on Earth. It happens very easily. And on Mars, it can happen as well.